creation of height maps based on vector source is of great benefit to CNC users. This easy method is fast, free, fully cross-platform and produces excellent results. Inkscape 0.47 or later is used for vector editing. 3D Sage is recommended for mesh displacement. Windows platforms can use bump bender if desired. MeshLab 1.2 or later is used for mesh editing. This method is proven on Windows XP, Windows 7 and the Linux CNC board distribution of Ubuntu 10.04 or EMC. Line art or stencil type vectors produce excellent results with a minimum of work. Many free vectors can be located via internet search engines. This example shows the process using Inkscape 0.47 on the Linux 10.04 platform. A line art style SVG vector is used as starting point. Basic editing techniques produce a higher resolution shaded height map. Inkscape is launched and document properties are established as 1080 by 1080 pixels. These are optimum settings for relief generation with bump bender. 3D Sage also generates high-quality output using these image dimensions. The Layers tab is opened. A new layer is added to offset the original vector. File. Import loads the vector onto the layer. Object. Align and distribute centers content on the page. The number 5 keyboard shortcut centers the document window. Object ungroup is used to allow separation of individual paths. Right-click on the layer allows fast duplication. The duplicate is renamed as base. The original layer is hidden and locked, preserving an unedited path. A new layer named as ring is added above the base layer. The base layer is activated and content is selected. Path, break apart, splits content into 58 individual fill paths. Object, fill and stroke, launches the fill and stroke panel. Fill color is set to none and stroke color is set to black. The panel is minimized. The view is centered and zoomed to allow selection of the outer path on the base layer. This path will form the relief base. Edit, invert selection, selects all non-base paths. Layer, move selection to layer above, puts all non-base paths onto the ring layer. The base layer is hidden and locked. A new layer named triangle is created above the ring layer. The ring layer is activated and the view is magnified, allowing selection of 2 paths that will create this element. Edit, invert selection, selects all non-ring paths. Layer, move selection to layer above, puts all non-ring paths onto the triangle layer. The ring layer is hidden and locked. A new layer named eye is added above the triangle layer. The triangle layer is activated and the view is adjusted to allow selection of the triangle element. Edit, invert selection, selects non-triangle elements. Layer, move selection to layer above, puts non-triangle elements onto the eye layer. The triangle layer is hidden and locked. A new layer named raise is added above the eye layer. The eye layer is made active and the view is adjusted, allowing selection of 6 paths that make up this element. Edit, invert selection, selects all non-height elements. Layer, move selection to layer above, puts non-height elements onto the raised layer. The eye layer is hidden and locked. A new layer, named Symbols, is added above the raised layer. The view is adjusted. The raised layer is made active, and 24 paths that make up this element are selected. Edit, invert selection, selects all Symbols elements. Layer, move selection to layer above, put Symbols elements onto the Symbols layer. Each design element now inhabits a separate layer for individual processing and shading. With the base layer active, the right-click menu is used to hide all other layers. View Guides allows two guides to be located at the document center. The readout at the lower right corner of the GUI displays mouse location to assist guide positioning. The base layer is unlocked and the path is selected. The fill and stroke panel is restored to apply shading. The ring layer is made visible to assist this process. Base layer fill is set as radial gradient. The Create and Edit Gradient tool is activated. Gradient control and adjustment handles appear in the view. Double-click on gradient control handles adds additional editable stops. This is performed 3 times, creating 3 extra control points. Double-click on existing stops opens the gradient editor to display or adjust settings for the selected stop. Using a Hue Saturation Luminance Color model, the first additional stop has luminance value of 130 with alpha value of 255. The second and third additional stops use luminance and alpha values of 255. The final stop uses luminance value of 0 and alpha value of 255. Base layer coloration starts in the center with opaque black. The gradient transitions to approximately 50% gray at the inner edge of the ring. It then changes to and maintains opaque white at the center of the ring area, followed by transition to opaque black at the outer edge. Gradient stop position is adjusted to control color transition below inner and outer edges of the ring element. The gradient editor is closed. The base layer is hidden and locked, and the view menu is used to hide guides. With the ring layer active, the outer path is selected. Shift left click on the inner path adds it to the selection. The path menu difference function cuts the inner path area from the selection, leaving a ring shape. The shape is duplicated with the right-click pop-up function. Select all below the edit menu, selects all shapes on the layer. The object menu clip set function assigns the duplicated shape as a clipping mask. Shading, blurring and stroke width effects are constrained to the area defined by the mask. Stroke paint is set to none. Fill type is set to flat color with luminance of 200 and alpha value of 255. A blur setting of value 6.1 is applied. Blurring softens inner and outer edges of the ring element. Colors in the base layer will show through, creating shaping based on color values in these areas. The ring layer is locked. The triangle layer is unhidden and unlocked. Guides are restored and the triangle layer is made active. Stroke paint is set to none. Fill type is set as radial gradient. The Create and Edit Gradient tool is used to adjust gradient handle position. Double-click on the center stop launches a gradient editor. Center luminance value is 45 with alpha 255. Outer luminance value is 150 with alpha 255. The gradient editor is closed, the triangle layer is locked, and the eye layer is unhidden, unlocked, and made active. Three paths are selected and combined. Path difference is used to cut the combined paths from the outer path. Center paths are processed with path difference. All paths on the layer are then united with path combined. Fill type is set to flat color with luminance of 130 and alpha value of 255. Stroke paint is set to none. The fill and stroke panel is minimized. The eye layer is locked and the GUI is adjusted for a clear view of the raised layer. Four paths that make up the raise element are selected. Path combine unites the paths to create a single entity. Guides are made visible and the fill and stroke panel is restored. Fill type is set as radial gradient. The Create and Edit Gradient tool is activated. Double-click on the center stop launches the gradient editor. Luminance value is 55 with alpha value of 255. The outer stop has luminance value of 160 with alpha value of 255. The gradient editor is closed. Stroke paint is set to none. The raise layer is locked. The symbols layer is unhidden, unlocked and made active. The right-click menu hides all other layers. Guides are hidden and the view is adjusted to allow editing of symbol elements. Path operations are applied to cut out or unite 5 of the individual symbol elements. Some multi-part elements require several operations, but these are very basic edits and do not take long to perform. This type of path editing should be familiar to the majority of Inkscape users. When these edits are completed, all elements on the layer are combined to form a single symbols entity. Fill type is set as flat color with luminance value of 230 and alpha value of 255. Stroke paint is set to none. The fill on stroke panel is minimized and layers are unhidden to reveal a basic height map. Some basic adjustments expand shaping options, provide for surface tracking detail, and apply edge softening effects. All layers except the rim layer are hidden and locked. The rim layer is made active. The fill on stroke panel is restored and the layers panel is minimized. The rim element is selected. Stroke paint is set as radial gradient. The panel edit button launches a gradient editor. Add stop inserts an additional gradient stop. The create and edit gradient tool is activated. The center gradient stop has luminance value of 45 and alpha value of 255. The additional stop has luminance value of 130 and alpha value of 255. The outer stop has luminance value of 0 and alpha value of 255. The gradient editor is closed. The stroke style tab is used to adjust stroke width. This applies curvature across the element surface as stroke width value is increased. Further shaping adjustment can be applied by variation of gradient stop location, luminance or alpha values, and layer blur setting. Experimentation is encouraged. The rim layer element is selected. Edit, copy, creates a duplicate of the element on the clipboard. The rim layer is locked. The symbols layer is unlocked and made active. Edit, paste in place, puts the copied rim element onto the symbols layer. The copy is placed on a sublayer above the symbols element. Object, lower to bottom, repositions the pasted rim sublayer below the symbols element. The fill on stroke panel is restored to set the copied rim stroke paint to none. Symbol layer blend mode is changed to multiply. Multiply mode darkens colors in layers below using gray values to control the effect. Where the multiply layer is black, maximum darkening occurs. Where the multiply layer is white, no darkening occurs. Where intermediate gray values are found, a degree of adjustment is applied. Where the symbols and rim layers overlap, the lighter symbols content causes less darkening of existing rim layer color values. This causes the symbols area to become raised while maintaining the form generated by the rim layer color mapping. The document properties panel is opened. Background color is set to opaque black. File export bitmap is used to save the height map to PNG format. A page option is selected to save using document pixel dimensions and the default resolution of 90 dpi. 3D Paysage is recommended for generation of relief meshes. The GUI is basic, but features provide full control over both mesh subdivision and topology. These aspects of the task impact on the quality of relief output and required system resources. Mesh topology can employ triangular faces or quads. Displacement based on triangular faces requires less geometry. Control over mesh subdivision allows user-defined mesh resolution. Use is quite simple. File Open Picture allows selection of the required height map. When the height map loads, number of divisions value is entered. For triangle-based meshes, a 1-to-1 pixel-to-face ratio produces the best results. Each square mesh division comprises 2 triangular faces. Division setting of 540 by 540 creates 1080 faces along each edge. Wireframe display mode is deactivated. A maximum displacement amount is established with a height max value. Pressing update generates the relief. File Export to Operant OBJ is used to save the relief using an identifiable file name. Windows users have the option of using Bump Bender for relief generation. Mesh subdivision is dynamically allocated based on image pixel dimensions. This image was adjusted to produce optimum results. A mesh measuring 12 by 12 inches with maximum available resolution of 90 plots per inch is generated. The GUI is adjusted for a better view of the relief. Relief height is established at 0.7 inches. Meshes having large detail may benefit from use of blur. Undisplaced areas can be trimmed by choosing a transparent background option. Export model allows the relief to be saved using STL format. MeshLab is a powerful geometry processor with many useful functions. Version 1.2.2 is easily installed from the default Linux repository. It has a slightly different look than later versions, but all required functions are fully implemented in this version. File Open. Loads compatible 3D geometry. OBJ geometry is subject to processing as loading takes place. The View menu hides the on-screen trackball, providing an unobstructed view. MeshLab uses a perspective view by default. With a cursor in the view, pressing Shift and rotating the mouse wheel establishes an orthographic view. View magnification is adjusted using the mouse wheel. Flat lines display mode ensures all faces are visible. The Select Faces by Rectangular Region tool is activated. A suitable region is dragged around required faces. The view is adjusted to confirm only displaced faces are selected. A filter inverts the selection. The Delete Faces and Associated Vertices tool removes unrequired faces. Smoothing is performed with an HC Laplacian smoothing filter. 1 or 2 applications should be sufficient. File Save As is used to save the mesh in STL format. STL content can be coded for carving using FreeMill or other 3D coding software.